Mr. Loggery here. Today we're going to look at Pythagorean Theorem, okay? The first thing you need to know is the parts of a right triangle, all right? So this long side that's yellow right here, this is called the hypotenuse. But what you really need to know is that that is side C. If you're ever not sure which side is the longest side, come down here to the right angle and go straight across. That's always the hypotenuse. These two other sides are called legs, okay? And we use A and B for those. Those can be interchangeable, but C always has to be the longest side that's across from here, okay? When we look at the Pythagorean theorem, what we're doing is you have sides A, B, and C, and the hypotenuse is always C. What the Pythagorean theorem says, if we make a square out here, and a square off of this side, and a square off of this one, then the area, okay, the area of squares A and B will equal C. But to get the area of a square, we have one side, and it's A, which means that all the sides are A. And to get area, you do length times width. So A times A gives us the area of this square. A times A, another way we can write that is A squared. Same thing here. If we want the area of B, we have to do B squared. And if we want the area of C, it is C squared. So the area of these two squares, if you have a right triangle, A and B, always add up to the area of C. And that's where the formula comes from, okay? So that's Pythagorean theorem. A squared plus B squared equals C squared. So let's look at this, okay? If we want to find the area of this green square, then we know it's going to be the sum of A and B right here. Because this is the hypotenuse. This is the right angle, the longest side of C. So we're going to look at the area of A. Well, that is a 4 by 4 square, so the area is 16. The area of B, it's a 3 by 3 square. You see how we got 3 here and 3 here? So 3 times 3 is 9. Well, the area of C has to be 25 because it has to be 16 plus 9. So the area of the green square is 25. To find the length, this should be a C right here. To find the length of side C, well, we have the area, right? But to get one side of it, we have to know that 5 times 5 makes 25. So one side of this square is 5. All the different sides are 5. That means the side C has to be 5 also. All right? We call that taking the square root. When you go from the area, let's say the area of this is 4. That would mean all the sides are 2, right? If we want to go from the area to one side, we take the square root of that number. This is what the symbol looks like. And the square root of 4 is 2. So the square root of 25 is 5. So that's one side. The area is 25. One side is the square root of 25, which is 5. Okay? Let's do the same for this one. This is 5. If we go across and we count 1, 2, 3, 4, 5. So this is 5 by 5, which is 25. 5 times 5 is 25. 1, 2, 3, 4. So this is a square that's 4 by 4. So the area of this is 16. Well, then the area of C is going to be 25 plus 16, which is 41. But to find the length of side C on this one, well, now we don't have a perfect square where we can get a square root of 41. Nothing times itself. No whole numbers will work for that. So for the length of side C, we'll just write square root of 41. And that's it. Because this whole area is 41, we need a number times itself that equals 41. And that's just the square root of 41. If you want to do it on a calculator and get the square root of 41, you can get a decimal. The square root of 41 is 6.4. So that looks about right. So the sides of this triangle down here, I'm going to write it over here so we can see. This one's 5. This one is 4. So you can see 4, and there's 5 across. This other side over here is the square root of 41, which is 6.4. And that makes sense because the hypotenuse is always the longest side. So this is a little bit bigger than 5 and 4. Okay, so let's do this one now. You'll notice this is C over here. This side is C. And this one's B. And this time we need A. So if we want to find the area of the green square, well, we know, well, this square is hard to read right here, isn't it? Something got shifted around. Anyway, we will pretend that this one down here is 25. And let's say that this square up here is, let's do 36. We'll say it's 6 by 6, okay? So we're going to say that this length is 6. Well, to find the area of the green square, we have to do a squared plus 25 equals 36. Now we got to do a little bit of algebra to get it, because we need to do minus 25 on each side. And that tells us that a squared equals 11. So the area, the a squared over here, a times a is 11. But for the length of side A, we have to take the square root of this. So if a squared equals 11, we do the square root to get a. So a equals the square root of 11, which is 3.3. That's an approximate answer. So you can leave them in a root form like that. That's a perfectly acceptable answer. If you want to write it as a decimal, use the calculator, round it to 1/10, okay? So now, to streamline this, because we're not going to sit there and make squares every time and add up the areas like that and count all our squares. So when you're using Pythagorean Theorem, you're saying a squared plus b squared equals c squared. And then you just find your lengths of your sides over here. You find a, b, and c. One of them's usually missing. You plug them into your formula and you use algebra to solve it. All right, so here's your steps. Identify the parts of the triangle. That's the most important part, finding C. You have to be able to figure out which one is C. After you find C, then you can just make the other two legs A and B. You're going to figure out which part is missing, and you're going to solve for the missing one. Let me show you what that looks like. We have a triangle. This side's 12, this side's 5. So we need to label the parts. We know that this is the longest side over here, so it has to be C, which makes this the right angle. That means we have A and B over here. So you need to figure out which ones are A, B, and C. On this one, C is missing, so we're going to write A squared plus B squared equals C squared, and we're going to memorize that. And then we're going to take this 12 and we're going to put it in for A. So we're just going to erase A, we're going to put in a 12. Then we're going to take this 5, it goes in for B. So we're going to erase B and we're going to put a 5 in. Then we're going to solve it. You can do this whole thing in a calculator if you want, or you can just do the math. 12 times 12 is 144 plus 5 times 5 is 25 equals C squared. When you add 144 and 25, you get 169 equals C squared. So now this is that area of the big square next to C. We need a side. So to get rid of the squared on here, we do the square root. And whatever we do to one side, we do to the other. So C equals the square root of 169, but that is a perfect square. That has a whole number answer. That means C is 13 times 13 is 169. So side C is 13. Okay? Let's do another one. On this one, We're looking for the side. The longest side is the one that's blank. The longest side is always C. And this is a right angle. That's 90 degrees. We're going to write the Pythagorean theorem out. A squared plus B squared equals C squared. If this is C, we can label either one of these A or B. It will work. C is the only one you have to get right. So now I'm going to take an 8 and put it in for A. Let me erase A, put in an 8. Over here, 15, B is 15. I'm going to erase B and put in a 15, and then I'm going to solve it. 8 times 8, 64, plus 15 times 15 is 225, equals C squared. 64 plus 225 is 289. Sorry, this should be an equal sign. Equals C squared. That's the area of the square along C. We need one side of it, so we take the square root of both of these. So C equals, the square root of 289 is 17. That's also a perfect square. It's a good idea to memorize those, up to 12 at least, probably all the way to 20. Now let's look at this one. Which side is missing? Well, the longest side is C, and if you have this little right triangle, the square, it's always, C is always opposite that. So this side is C, which means this is A and B over here, any order. We got to get C right. We're going to write the Pythagorean theorem. A squared plus B squared equals C squared. A is 4. I'm going to erase A, erase that. Why isn't it erasing? There we go. Put in a 4. B is 8. So I'm going to put an 8 for B and then solve it. 4 times 4 is 16 plus 8 times 8 is 64 equals C squared. 16 plus 64 is 80 equals C squared. This is the area. I need one side, so I take the square root, and C equals, this is not a perfect square, so you can just write the square root of 80. If your teacher wants you to simplify this, then simplify it, but this is good for my class right now. So this side is the square root of 80. And then you check that, check it in a calculator. The square root of 80 is 8.9. And then I look to see, is that longer than 4 and 8? Yes, it is. C should be the longest side. So that passes the reasonableness test. You want to look at it and see if the number makes sense. And that looks like this side's probably about 8.9 or 9. Okay? So let's look at this one. Find the side that's missing. This is C, because it's right across from there and it's the longest side, which means we have A and B over here. Doesn't matter which one. You could switch that. In fact, let's just switch it around. I had A here. Let's do this one B and this one A. That doesn't matter. You got to get C right. Right? The Pythagorean theorem. C squared. A is 14. So I put a 14 in for A. B is 12. Put a 12 in for B, and then solve it. 14 times 14, 196, plus 12 times 12, 144, equals C squared. 196 plus 144 is 340, equals C squared. C squared is the area. We need a side, so we got to do the square root of both of them. C equals square root of 340. And that's how long side C is, square root of 340. Do it in a calculator to make sure it looks right. 18.4. Well, side A and B are 14 and 12. This one's longer. 18.4 looks reasonable to me. All right. Find your missing side. Looky here. C's missing again. Means we got A and B. Just get C right. A and B can be in any order of the two legs. I'm going to write the Pythagorean theorem. A is 17. I'm going to put a 17 in for A. B is 6. I'm going to put a 6 in and then solve it. What's 17 times 17? 289. Plus 6 times 6 is 36. Equals C squared. 289 plus 36 is 325. So that's the area. C squared is the area. To get C, we want to do the square root. It's the square root of 325. Plug it in a calculator, check it, see if it sounds right. Right at about 18. So 6, 17, 18. C should be the longest side. Looks good to me. Okay. On this one, C is 11, which means the other two are A and B. You can pick if you want the missing side to be A or B. I normally choose A for the missing leg if I have a missing leg because it makes it a little easier to see what to do in a step that's coming up. But you can do it either way. Make sure you get C correct every time, okay? That's the important one. Then assign A or B to whichever. So I'm going to write the same way I've been doing. A squared plus B squared equals C squared. A, I don't know this time. B is 6. So I put a 6 in for B. C is 11. So I put 11 for C. But now you can see the number we plugged in is on the other side of the equal sign. So this is going to create a little bit of an extra step. So you have to label A, B, C correctly and then set it up right. But now we still work it the same way so far. A squared plus 6 times 6 is 36 equals 121. That's 11 times 11. Now you have to use a little algebra because we want this A squared. That's the area of this square that's out here. If you had a square right here, that's the area. We want to get rid of this plus 36, and we do that with our algebra by subtracting 36. If we do it to one side, we do it to this side also. That's going to give us A squared because this now cancels. Equals 121 minus 36 is 85. That's the area of this square over here. We want one side, so we take the square root to get A. A equals the square root of 85. So that's how long this side of the triangle is right here. It's the square root of 85. So let's do square root of 85. See what it gives us as a decimal. It's 9.2. So this side is 6. The hypotenuse is 11. So our side should be smaller than the hypotenuse, right? And 9.2, and that looks about right. It looks longer than this one, but shorter than that one. So it looks good. All right, on this one, C is 5. I'm going to label my empty leg A, and this is B. I'm going to write the Pythagorean theorem. Then I don't know what A is, so I leave it alone. B is 3. So I'm going to put a 3 in for it. C is 5. So I'm going to put a 5 in here. Then solve it. A squared plus 3 times 3 is 9 equals 5 squared is 25. I'm going to get rid of this plus 9 by doing minus 9. If I do it on one side, I have to balance, so I do it to the other. This cancels. A squared equals 25 minus 9 is 16. That's the area. I need to take the square root to get A by itself. Be careful on this. This is a perfect square. The square root of 16 is just 4, which means this side's 4. 3, 4, 5. Okay? I don't know what happened on that picture. Let's skip that one. Okay, find the length of the missing side. We've got 4, 8 is C. I'm going to make my missing leg A and this leg B. A squared plus B squared equals C squared. I'm going to write the Pythagorean theorem. I'm looking for A, so I leave it alone. B is 4. Put a 4 in here. C is 8. Put an 8 in for C and solve. A squared plus 4 times 4 is 16. 8 times 8 is 64. Anytime you're solving for a leg, an A or a B, you're going to have to do this subtraction step. So I'm going to do minus 16 to cancel that. Both sides cancels. A squared equals 64 minus 16 is 48. The square root to get my side, A equals square root of 48. Make sure that this is simplified enough for your teacher if you're in someone else's class, but square root of 48 is the answer. That will simplify in radical form too if you need to do that. For my students, radical 48 is perfect. Then let's take the square root of 48. It's 6.9. And make sure that makes sense. We got 4, 6.9 for leg. 8 is still the longest. It looks pretty reasonable. Okay, this is the last thing we're going to do. We're going to test and see if this is a right triangle. You do it the exact same way, okay? Remember, A squared plus B squared equals C squared. That means the area of the two smaller, the squares that we grow out of the two smaller sides is always equal to the largest side, the square off of it. These are easy to label because we know the largest one has to be C, then the other two have to be A and B. This time we're just going to put all of them in, okay? Instead of A, we're going to put a 5. Instead of B, we're going to put a 7, 5 and 7. And C is 11, so we're going to put an 11 here. Then we're going to do all the math on it. 5 times 5 is 25, plus 7 times 7 is 49, equals 11 times 11 is 121. 25 plus 49 is 74, equals 121. But this number is the two squares added up. And we know that for it to be a right triangle, they have to equal the square of the big side. They do not, so this is not a right triangle. So if you're just doing yes or no, you would put no or false. For it to be a right triangle, these numbers have to equal each other. Okay? Same thing on here. Write out Pythagorean theorem. A squared plus B squared equals C squared. The largest number is C. The other two are A and B. You can put those in any order. You just have to get C right. A, we said we're using 8. B, we're using 6. Erase. C, we're using 10. 8 times 8, 64. Plus 6 times 6 is 36, equals 10 times 10 is 100. 64 plus 36 is 100, equals 100. The two areas of the smaller sides are the same as the area of the bigger side. This is yes, it is a right triangle. Okay.